we now turn our attention to Newton's laws. There are three laws that Newton proposed that will form the foundation for all the work we do in this course. So the first of these laws is often referred to as the law of inertia. What this law states is that if I have some object, so this is some object, let's say an apple, and it is at rest, then this object will remain at rest unless some net force acts on it. Pay attention to the word net force. There may be many forces acting on this object, but if they all cancel out, the net force is then zero. So in order for this stationary object to move, there must be some non-zero net force acting on this object. So that's the first half of this law, the first law. Now if this object happens to be moving, so let's suppose it's moving, and I'm not a good artist, so I don't know how to make this look like it's moving. Maybe doing something like that. I don't know. If this object is moving, it will move in a straight line, so that's a straight line with a constant speed. So the speed will be constant and the direction of travel will be constant. Of course, this can be summed up as saying that the velocity will be constant. So if the net force acting on this is zero, this object will move at a constant speed and in a straight line. Often this law is given as follows. If an object is at rest, it will remain at rest, and if it is moving, it will move in a straight line and at a constant speed unless some net force acts on it. So that is what I was saying here. If this object isn't moving, the only way you can get it to move is if some net force acts on it. And if it's moving, the only way you can make it speed up or slow down or change direction is to have some net force act on it. As long as the net force is zero, and remember the net force can be zero if 1, there are no forces acting on it, or 2, if the forces that do act on it cancel out. So if the net force acting on this object is 0 and it's at rest, it will remain at rest, and if it's moving, it will move in a straight line and at a constant speed. To get it to change direction or to change speed, some net force has to act on it. So let's look at a little cartoon that can maybe make this a little bit clearer. Here we have a little applet, and this is the website, the URL. And what we have here is an apple that is at rest, and it will remain at rest unless some force acts on it, compelling it to change its state of motion. So there's a background here, and it looks like a tree. So you may be tempted to say, well, what about gravity? Well, we just have this background here so you can detect motion, so you can see when it's moving. So you're going to have to stretch your imagination a bit and accept that where this apple is, there's no gravity. There's no force at all acting on this apple. Remember, all I'm trying to do here is get you to understand an idea, like what is it that Newton's first law is saying. This is not an experiment by any stretch of the imagination. So this apple is at rest, and it will remain at rest. There's no force acting on it. So when I click this little icon here, a force will be applied only for a brief moment, but that force will cause this apple to change its state of motion. So there we go. And now the apple is moving. Notice there is a little worm inside. So this scarf seems to be fluttering in the air, and the artist, I believe, drew this just so you can get the idea that this thing is moving. Likewise, these lines here are to convey the idea that this apple is moving to the right, and we see the background zooming by to the left. Again, this is only so that you can see the motion. We have to assume here that there's no force acting on this apple. There's no gravity and no air resistance. Absolutely no force. Since there's no force acting on this apple, it will continue to move in a straight line and at a constant speed forever and ever and ever. If I want to make it move faster, I have to apply a force. This applet doesn't come with that ability. And if I want to slow it down or stop it, I need to apply a force. So here we're going to bring it to a sudden halt. And I do so by simply clicking this. Now notice what happened. We don't see the apple anymore. The apple was brought to a halt. However, the force that was applied only to the apple, not to the little worm. And so the worm continues to move. This worm will only come to a halt if some force acts on it. And now the worm is brought to a halt. So the wall exerted a force on that worm, and that's how the worm's state of motion changed. Before we finish our little discussion of Newton's first law, let's make sure we understand the meaning of this word inertia. The inertia of an object is that property of the object that makes it remain at rest if it's at rest, or if it is moving, it's the property of that object that makes it want to move at a constant speed in a straight line. In other words, the inertia of an object is an expression of its reluctance to change its state of motion. An object's state of motion will not change unless some net force acts on it. So inertia, when we say inertia, we are referring to that property that all objects have, whereby their state of motion will not change unless some net force acts on them. Newton's first law can be summed up in this mathematical expression. Here we are saying that if the net force is 0, then the acceleration has to be 0. So this little sum sign means the vectorial sum of all the forces acting on an object, which would give us then the resultant force, or the net force. So if the net force is 0, the acceleration has to be 0. You should realize that if the acceleration is 0, then that means that its state of motion is not changing. If it's at rest, it's remaining at rest, and if it's moving, neither its speed nor its direction of travel are changing. The converse of this is also true. If the acceleration of an object is 0, that is, if it's moving in a straight line at a constant speed, or if it's at rest, then the net force acting on that object has to be 0. So that brings us to the end of this little discussion of Newton's first law. In the subsequent videos, we'll discuss the other two laws.